Hello, our probability video for today is going to be looking at conditional probability with independent and dependent events. So conditional probability, what is that? Conditional probability is the probability of an event B given that event A has already occurred. So the probability of event B given that event A has already occurred. And the way we write this is the probability of B given A has occurred. So what that means, it's probability that meets a certain condition, which means the sample space has changed. Probability that meets a certain condition, which means, oops, was one word ahead, that means the sample space has changed. All right, so one event given another event has already occurred. And then we have two kinds of events. We have independent events and we have dependent events. So think about independent and dependent variables in science. You probably learned all about this. This is something that you should be familiar with. We have talked about independent and dependent variables in math as well. X depends on Y. We know all about that. So the independent event, when the occurrence of one event does not affect the other. They are independent of each other. So when the occurrence of one event does not affect the occurrence, spelling error, the occurrence of the other event. So think about flipping a coin. When I flip a coin, I get heads, for example. If I flip the coin again, I still have the same probability. Just because I got heads the first time, it's not going to change my sample space for the second flip. I still have the option of heads and tails. So the sample space hasn't changed. They are independent events from each other. The way we write this is if I have the probability of A and B occurring, but those two events are independent, so they don't depend on each other, we take the probability of A and we multiply it by the probability of B. So if we're trying to figure out if I get a heads and then a tails, because those events are different, I just multiply their probabilities together. Now, dependent events, however, are when one is going to affect the other. So when the occurrence of one event does affect the occurrence of the other event. So when they are related to each other and they affect each other, the probability is going to be a little bit different. So if I have the probability of A and B, but they are dependent, I take the probability of the first event A, because that's the first thing, nothing has changed yet. And then instead of just doing the probability of B, I have to do the probability of B given that A has already occurred. So just to remember that this is B given A has already occurred. They are dependent on one another. So if we think back to our first definition, in conditional probability are the events independent or dependent? They are dependent because the second event is based on the first event happening. Dependent. The second event is based on the first event occurring. So conditional probability is going to be dependent events involved. So, okay, we're looking at our examples here, bringing everything together. You have a bag, and this bag is containing 20 marbles. There are 10 blue, 6 purple, 3 pink, and 1 green. We just double check. 10 plus 6, that's 16, 19, 20. So we've got 20, good, total of 20. We don't have any missing marbles there. Okay, so we're going to randomly select a marble without looking into the bag. So we're going to do a couple different things. We're going to determine if the following are independent or dependent, that's part A, and then we're going to calculate the probability. So for number 1, what is the probability that you select a blue marble on the first try? And then here's the key. We're going to replace that marble. We're going to put the marble back into the bag. Then we're going to select a green marble on the second try. So when we're trying to decide if they are independent or dependent, for part A, these two events are independent. The reason is because if I pick a blue marble and I put it back in the bag, my sample space isn't going to change. I still have the same likelihood of picking the same blue marble in the same bag of 20 marbles. So the probability there, if I want to calculate the probability of blue then green, I'm simply going to multiply those two together. So the probability of blue times the probability of green. Now when I'm looking here, I see that there are 10 blues. So the probability of blue, that's 10 out of the total 20. Now I'd probably reduce that down to 1/2. The probability of green, I see that there is 1 green out of the 20. So I have 1/2 times 1/20. When I multiply 1 times 1, that gives me 1. 2 times 20, that gives me 40. So my probability is 1 out of 40, which is 0.025. All right, let's look at the next one. What is the probability that you select a purple marble, set it aside, and then select a pink marble? So now when I take that purple marble out of the bag, I'm not replacing it. And since I'm not replacing it, my bag no longer has 20 marbles in it. It only has 19. I have changed my sample space. Therefore, these two events are dependent events. So the probability of choosing a purple, then pink, is the probability of purple times the probability of pink, given that the purple has already been taken out of the bag. So pink given purple has already occurred. Now the probability of purple, if we look back up, there are 6 purples out of the 20. So that reduces down to 3/10. You don't have to reduce if you don't want to. Now the probability of pink, when I look at what we have, there are 3 pinks, so I'm multiplying that by 3, but it's not 3 out of 20 anymore. There are 3 pinks, but the bag of marbles only has 19 marbles in it. So my probability of choosing pink given purple has already been taken out is 3/19. So I'm doing 3/10 times 3/19. 3 times 3 is going to give me 9 in the numerator. 10 times 19 is 190. That doesn't reduce down, which is about 0.047 of a probability. We're moving on over to that second page of your notes. So we've got our directions here again with all of our marbles and all of our colors, so we don't have to flip back and forth. What is the probability that you select 2 blue marbles with replacing it after the first one? Okay, so that key is, am I replacing it or am I not replacing it? Because I'm replacing that marble, these two events are independent. So the probability of picking blue, then blue, is the probability of blue times the probability of blue. I put that marble back in the bag, so I don't have to change anything about my sample space. Looking here, there are 10 blues and 20 total, which is 1/2. Now that second marble pull is still 10 out of 20 because I put the blue marble back in there, so it's just as likely. So it's 1/2 times 1/2, making that 1/4, which is 0.25 probability. Hopefully it's all starting to come together and make sense. Number 4, what is the probability that you select 2 purple marbles without replacing? All right, so this time when I take the first purple one out, I don't put it back in. That means we've got some dependent probability here. So the probability of purple, then purple, with dependent events is the probability of purple times the probability of purple given purple. So the first one, get nice and easy. We look up and we see that there are 6 purples. So the probability is 6/20, which reduces down to 310. Again, you don't have to reduce it if you don't want to. It just makes it easier later on. Now my second probability here of purple given purple, there were 6 purples in that bag, but I took one of those purples out and I set it aside. So now I no longer have 6 purples in the bag. I only have 5 purples in the bag. And I no longer have 20 marbles. I have 19 marbles. 5 out of 19, that doesn't reduce. So I've got 3 times 5, which is 15. 10 times 19 is 190. That one does reduce down to 3/38, which is about 0.079 probability. Number 5, what is the probability that you select 2 green marbles without replacing? So once again, I'm not going to put that marble back in the bag. Oops, the last one I wrote B. That's an A. A is dependent. So I want the probability of green, then green. Because they are dependent, it's the probability of green times the probability of green given green. All right, so we look up above at all of our information, and there's only 1 green in that bag, so the probability of the first one is 1 out of 20. So the probability that I pick out 1 green marble is 1 out of 20, but I'm not putting that marble back in the bag. So there's 2 things going on. I don't have any green marbles left in the bag, and there's only 19 marbles left in there. So this actually has a probability of 0%. There is no way for me to select 2 green marbles from the bag because the bag only has 1 green marble. Now, if this was independent events and I had put the green marble back in the bag, then we could calculate that probability, but because it was dependent, it's not possible. Our last one, what is the probability that you select a blue one, and then a purple one, and then another blue one, all without replacing? So we didn't replace it, so we know it's dependent. We've got that down by now. So I want the probability of blue, then purple, then blue again. So this is going to be the probability of blue times the probability of purple given blue times the probability of purple. Oops, I wrote given, sorry, given blue. Oh my goodness, look at all of that. Sorry. So first one, probability of blue, we're good. And then purple, so purple given blue, and then we want another blue. So then it's probability of blue given purple given blue. Sorry if I confused there for a second. My head and my brain, or my brain and my hand were not in sync together. All right, so let's go ahead. Blue on the first try. That's what we're concentrating here. Blue, blue. We look and there are 10 out of the 20 blues. And then I go on to my second pull of purple. I didn't put that blue back in. But I still have all of my purples because I didn't choose a purple yet. So then that's times 6 out of 19. I still have all 6 purples in the bag, but my sample space is now only 19 because I had taken 1 blue out. That does not reduce. And then last, another blue. All right, so we started with 10 here, but I took one of the blues out. So now I only have 9 blues left in the bag, and we've got 20 over 19. I now only have 18 left there. 9 out of 18, that also reduces down to 1/2. So I've got 1 times 6 times 1, that's a 6 on top. 2 times 19 times 2 gives me 76 on the bottom. Reduce that, we get 3 over 38, which is about 0.079. All right, that was our independent versus dependent day video, and we are all set.